This video will walk you through how to build portfolios in Excel, how to estimate the return and standard deviation of a portfolio, how to find the minimum variance portfolio, how to find the tangency portfolio or the portfolio that maximizes the Sharpe ratio, and how to allocate money between the tangency portfolio and a bond to achieve a desired level of risk, and then find the return that an investor can achieve for that desired level of risk. So we're going to do a lot here. A lot of steps. Really, we only need 2 or 3 numbers at the end, but you have to do things in order to get the right result. So for this project or for this analysis, you will need the Solver add-in installed, and I'll have a link on Blackboard to show you how to do that. But if you're on a Mac, you can go to your Data tab and click on Analysis Tools, and make sure Analysis Tool Pack and Solver are built in. So this is the Analysis Tool Pack that we were using before, so that should be checked. And the Solver add-in is the one that we need. So make sure you hit that Solver. Click that Solver button. On a Windows machine, you have to go through a slightly different menu, but it's not complicated. I'll have a link for you to do that. And you'll know you have it right if you see Solver down here under the Data tab, Data ribbon. Now, if you go to the Home tab, there is a Solver thing here. I'm not exactly sure what that is or what that does, but this is not the one we're going to be using. It might do the exact same thing. It just is set up in a different way that I'm not as familiar with. So we will always use the Solver function that's over here under this Data tab. So the data that I'll give you a spreadsheet that's set up in a way that's similar to this, but we already have the returns calculated. So I have 5 months of returns for Microsoft, Apple, Amazon, and Meta. I also had NVIDIA in here earlier because those where I pulled the top five stocks that make up the S&P 500 index. But throwing NVIDIA in there created some weird results, so I went ahead and dropped that just for this example. But that's why I pulled. That's why these 4 stocks are here. These are some of the largest components of the S&P 500 by weight. So notice I have it down here. A few rows down, then I have portfolio over here to the right. Above it, all I've done is I've replicated the stock ticker names at the top because I need to generate the average, standard deviation, weights, add some weights and stuff above it. So it just makes it easier if it's organized this way. There are other ways to do it, but I think this is the easiest way to organize the spreadsheet. For the average, I need the average of the Microsoft column. So I'm just going to click there, Command-Shift down to go to the bottom of that data. For standard deviation, I want to start with Microsoft, go all the way down. So this is going to be the average and standard deviation of this column right here. And I'm going to click on these and I'm going to drag it over to Meta. And now we can see we've estimated the averages and standard deviations for all of those columns. So if we're just looking at this, we can see that Meta has the highest standard deviation, but also the highest average return. Amazon has the next highest standard deviation, but not the next highest return. Apple has a higher return than Amazon. And our returns are all from 1.28% to 2.51%. So we could plot these and look at the kind of thinking about a efficient frontier type problem where we plot these and we can think about all the different combinations of them. But we're going to do that in a slightly different way here because trying to estimate the efficient frontier and plot it is actually quite difficult in Excel. So we need to take these 4 stocks and we need to build a portfolio. So when we think about building a portfolio, all we're doing is trying various combinations of these 4 stocks to give us a portfolio. So we could put an equally weighted portfolio. We could do 25% of each. We could do all of one, none of the others, half, zeros. There are an infinite number of combinations that we could try here. So I always start with an equally weighted portfolio just because it's easy and it helps you check your math on the front end to make sure everything's working like it should. So what I'm going to do for the weights, I'm going to set each one of these to 0.25. So they have to add up to 1. We have 4 stocks, so I'm going to set them to all to 0.25. And the next thing I want to do is add these weights up. And this seems like a silly thing to do now, but when we use the solver function later, we have to have a constraint. So we're going to maximize some objective or minimize some objective subject to a constraint. And the sum of weights, this is to be equal to the sum of the weight cells. And I'll show you why it's important to do it this way. So notice that adds up to 1. Let's say I incorrectly put 0.3 here. Now my weights add up to 1. I can very quickly see that I have a problem because my weights are adding up to a number that's greater than 1. So if I put this back to 0.25, the sum of the weights add up to 1, so we know everything looks right so far. Do not put the number 1 in this box. It has to be equal to 1, but 1 has to be the result when we sum these 4 cells, or however many stocks you have. So we always want this to equal 1, but we have to get there by summing these weights. If you put the number 1 in that cell, you're going to get a major problem when you try to, or you're going to run into some major problems when you use the solver function. Right. So the next thing we want to do is build a portfolio. So what we're going to do first is build an equally weighted portfolio. So this portfolio will have an equal weight of Microsoft, Apple, Amazon, and Meta. And the way we do that is we have to multiply the monthly returns by the weights. And that's how we get the monthly return for the portfolio. So it's going to be the weight of Microsoft times the return Microsoft, weight Apple, return Apple, weight Amazon, return Amazon, weight Meta, weight Meta, and return Meta. So the way we do that, we're going to use a sum product function. And we are going to highlight the weights, but you have to be sure and put the dollar signs in front of these cells. So you have to make sure you have the dollar sign in front of the B4, the B, the 4, the E, and the 4. If you don't do that, when you drag the formula down, you're not going to be multiplying by the weights, you're going to be multiplying returns by returns, which is not what you want to do. So the first row, or the first argument in the sum product function are the weights, and then we want to highlight the returns. Close this, hit enter, and then we want to run this down. You'll know it's right if you just click some random cell and you're multiplying that row of returns by the weights. So if you click any of these, we can see we're always multiplying by the weight. Well, too far down. We're always multiplying returns by the weights, returns by the weights, returns by the weights. So you want to do that for everything. So since this is an equally weighted portfolio, this 10.06% should just be the average of these numbers right here. So we can check that just quickly. You don't have to do this. This is just to make sure everything's working correctly. If we just take the average of these, we get 10.06%. And that works because we started with an equally weighted portfolio. So all 4 of those are getting an equal weight. This is just one way to check your math to make sure everything is working correctly. So if we come down here, do the same thing, take the average of these 4, everything's working correctly. I will show you how to figure out if it's not working correctly. So I'm going to do it the wrong way here. So just to help you avoid this mistake in the future. All right. So I'm going to do the sum product, and I'm going to multiply this. Actually, I'll do it in the same order I did before. The weights multiplied by the returns. Close it, hit enter, and run this down. This first one's going to be correct, but none of the other ones are going to be correct. So notice what happens when I click here. I'm multiplying returns by returns, which is not what we want to do. That's why you have to be really careful to put the dollar sign in front of everything in the weights row. So when you run that down, you get weights by returns in every cell. So that's one of the biggest mistakes I see here, so make sure you don't make that mistake. Now all I'm going to do is drag this over so that now I can have the average of the portfolio and the standard deviation of the portfolio. So average of the portfolio is easy. I could have just multiplied these returns by these weights to get that average. But I always want to work with the column, because now if I change the weights, the portfolio column will change, and this will change as well. So we can see when we put this portfolio together that's equally weighted, we get an average of 1.88%, which is exactly what we get. Notice down here, if we just average those cells, that's what we're getting. But remember from the notes, the variance of a portfolio depends on all of the covariances of the components in the portfolio and the individual variances of the components of the portfolio. All of that's already baked into this calculation right here when you set up the portfolio column this way. Because each cell here is already incorporating the weights. So this does all of that really long, complicated calculation for you, and it's summarized right here in this standard deviation number. So that's the square root of the variance, which is all the stuff we talked about before. Another quick way to check your math here to make sure it's working, if you set all of your weights to 0 except one of these, notice my portfolio is exactly equal to meta. Because 100% of my portfolio is in meta, the portfolio return should be identical to the meta return. If we do it for Microsoft, notice the portfolio return is identical to the Microsoft return. So that's another way to check your math to make sure everything's working correctly. So I'm going to go back to equally weighted here and put everything together. So that's how we set up the portfolio. So the next thing we want to do is determine the minimum variance portfolio. So how do we choose the combination of Microsoft, Apple, Amazon, and Meta to give us the smallest possible standard deviation, or the portfolio with the least amount of variance? And if you minimize the variance, it's the same as minimizing the standard deviation. So the way we do this is we go to the Data tab, go to Solver, you can delete anything you see because it's just left over from some previous problem. The objective we want to set is the standard deviation of the portfolio. So I'm going to click right here for standard deviation. So my objective is going to be the portfolio standard deviation. I want to minimize that by changing the weights subject to the constraint that my sum of weights is exactly equal to 1. And hit OK. So we're telling Excel, I want you to search through all the different combinations of the weights. That's what changing variable cells means. I want you to change the weights so that the standard deviation of the portfolio is minimized. But I need to make sure the sum of the weights add up to 1. I need to allocate all of my money somewhere among these 4 things. You can't do less than or equal to 1 because it will set the sum of the weights to 0 and invest $0. So the easiest way to have no risk is to not invest anything if you're trying to minimize the standard deviation. So objective, standard deviation, minimize by changing the cells, by changing the weights, subject to the constraints, the sum equals 1. And this is why we can't put the number 1 in that box, because that constraint would always be satisfied. That's why the sum of weights cell has to reference the weights above it. Right. Hit solve, hit OK. And notice it allocated money between Microsoft, Apple, and Meta. So the minimum variance portfolio right here has 73% of the portfolio goes to Microsoft, 26% of the portfolio goes to Apple, and 2% of the portfolio goes to Meta, and nothing is allocated to Amazon, which is a little bit interesting since Amazon is not the highest standard deviation. Meta actually has a higher standard deviation than Amazon, but what's going on in the background are all of those covariance terms and how Microsoft, Apple, Amazon, and Meta are correlated with each other is driving part of this result. And that's the part that we can't see because it's happening in the background with that solver function. But we can see right here that the minimum variance portfolio has a return of 1.86% and a standard deviation of 6.33%. So 1.83% is the return on the minimum variance portfolio. 6.33% is the standard deviation of the minimum variance portfolio. And we saw earlier when we were thinking about Sharpe ratio in the previous section that the minimum variance portfolio it's unlikely that will be the optimal portfolio for anyone, because if your goal is to minimize risk, you go to a bond or you go to something else. But you're going to have a lower return. If you put the money in the bond, you're going to end up with a lower return more than likely than you would with that minimum variance portfolio. So what we have to think about next is the tangency portfolio and estimating the Sharpe ratio. So the Sharpe ratio is always, it's a formula that you have to enter here. So it's always the portfolio return minus the risk-free. So it's the return on the risky thing minus the risk-free return, and then to divide that by the standard deviation of the risky thing. So in this case, 1.86 minus 0.5%, that's the risk premium, or that's the return that's above and beyond the risk-free rate. Divide that by the standard deviation of the portfolio, and that will give us the Sharpe ratio, which is 0.22. Again, that number, its magnitude on its own doesn't mean much right now, but we can use that Sharpe ratio to compare different combinations of stocks that fall on that efficient frontier. So right now we know that the minimum variance portfolio is on the efficient frontier, but we know it's the bottom leftmost point on that frontier. So that's where the efficient frontier starts. Now we have to think about moving up and to the right on that frontier, then trying to figure out where or which combination of Microsoft, Apple, Amazon, and Meta is the tangency portfolio. Which one gives us the maximum Sharpe ratio? So the way we maximize the Sharpe ratio is we're going to go back to our solver function, and we're going to set our objective to the Sharpe ratio. So instead of minimizing the standard deviation, we want to set the objective to the Sharpe ratio, and we want to maximize that. And you can leave everything else the same because we still want to change the weights, and we still need the sum of the weights to add up to 1. So when we have our parameters here, the objective for Sharpe ratio should be the Sharpe ratio that you calculated earlier, or that cell where you entered the formula for the Sharpe ratio. We want to maximize it by changing the weights subject to the same constraint, and hit solve. And we can see we have a slightly different allocation. So we're still ignoring Amazon. Amazon is still being left out of this portfolio, but we now have different weights. So our new return is now 2% and a standard deviation of 6.65%. So notice compared to the minimum variance portfolio, our return's higher. It was 1.83% on the minimum variance portfolio. It is 2% now. And the standard deviation of the minimum variance portfolio was 6.33% compared to 6.65% now. So the portfolio that we have now actually has slightly more risk than the minimum variance, but the return is high enough to compensate us for that risk. So we're moving up and to the right on that efficient frontier. And now this is the point that maximizes the Sharpe ratio, given the risk-free rate is 0.5%. Now, if we change that risk-free rate, the tangency portfolio is also going to change. Because as the risk-free rate increases, our tangency portfolio will move up and to the right along that efficient frontier. So right now we're allocating 47% of the portfolio to Microsoft, 31% to Apple, and 21% to Meta. So notice this is getting more weight than it got before. In the previous example, that 11.89% standard deviation was causing us to put very little money into Meta, but now notice the return for Meta is the highest. So we're putting a little bit more weight into Meta because the return is higher. Even though the standard deviation is higher, we allocate a little bit more money there now because that Sharpe ratio considers the return and the standard deviation. We're not just looking at minimizing the risk. So this is what we would call the tangency portfolio. And for the remaining part of the problem, this is where we have to start. Because if we're going to set a desired level of risk, we have to allocate the money between the bond and the tangency portfolio, not some random portfolio that's just some random combination of these four stocks. So what we can do is set a desired level of risk equal to, I'm just going to say 1%. So let's say this investor is comfortable with a standard deviation of 1%. The way we allocate the money between the tangency portfolio and the risky stuff is we take the desired level of risk and we divide that by the standard deviation of the portfolio. And that's going to tell us how much of the money, how much of the overall portfolio should be in the risky stuff. And since their desired level of risk is 1%, which is much closer to the bond of 0.5% than it is to the tangency portfolio, it's not surprising that we're allocating most of our money to the bond to achieve that desired level of risk. And if we allocate 15% to the stock, 85%, or 1 minus that, is what goes to the bond. So since our desired level of risk is so close to the bond level of risk, we're putting 85% in the bond, and we're putting 15% in the risky. So this is how we allocate the money between the tangency portfolio and the bond to achieve a standard deviation of 1%. Now notice what happens. So we have 6.65% here. I'm going to put 3.325 right in the middle. Notice we put exactly half of our money in the stock and half of our money in the bond. So let me give myself a few more decimal places here so you can see that. So if my desired level of risk is exactly half of the standard deviation of the tangency portfolio, I put exactly half of my money in the risky and half of my money in the bond. So let's say I want my desired level of risk to be exactly equal to the tangency portfolio. If I want the bond level of risk, I'm going to put we're going to start allocating more towards the the desired level of risk for the bond is 0. This is the return on the bond. If I want no risk, I put everything in the bond and nothing in the stock. So you can play around with this and see how much of the portfolio should be allocated to one portion or the other for some desired level of risk. Again, but the risk-free return is only going to give us 0.5%. So the next step is to figure out, of this 15% that goes to stock, how much of it actually goes to Microsoft, how much goes to Apple, how much goes to Amazon, how much goes to Meta. So to calculate that, what I like to do is just copy these tickers here, just to keep things in the same order. And we can calculate the share that we're going to, well, that needs to go down 1. And we can find the share that goes to Microsoft, to Apple, to Amazon, and to Meta. So the way we allocate the money between these four stocks depends on the weights that result from the solver function. So 15% goes to stock. Of that 15%, 47% of the 15% needs to go to Microsoft, 31% of the 15% goes to Apple, and 21% of the 15% goes to Meta. So the way we do this is we're going to take the share stock, make sure you put the dollar signs around it. You can do F4, we'll do that for you. Or you can just manually add the dollar signs if you want to. We want to do that share stock, and we want to multiply that by the weights. And this is why I kept everything in the same order. So when I drag this over, I know everything is going to work correctly. Format those as a number to give ourselves 2 decimal places. And now we can see how we're allocating money between Microsoft, Apple, Amazon, and Meta. So since 15% total goes to stock, the sum of these weights, you can see right down here, is 0.15. So we've allocated our money across these 4 things based on their share of the Tangency portfolio and the share that we put in stock that results from this desired level of risk up here. So this portfolio would be 85% bonds, 7% Microsoft, 5% Apple, and 3% Meta. And that would give us a standard deviation of exactly 1%. So notice what happens if our desired level of risk increases. So let's say we're okay with a standard deviation of 5%. Well, we're now putting 75% in the stock, 25% in the bond. Of that 75% that goes to stock, 36% goes to Microsoft, 24% goes to Apple, and 16% goes to Meta. So we're using the share stock that comes from our desired level of risk with those weights from the Tangency portfolio to allocate the money across those things. The last piece of information we need is the return on this portfolio. So the return on the portfolio that gives a desired level of risk of 0.5% is going to be equal to the share that we have in the stock or in the Tangency portfolio multiplied by the return on the Tangency portfolio plus the share we have in the bond times the bond return. So it's just the weighted average of the portfolio and the bond, and we can do that using the share stock and share bond results that we get up here and the Tangency portfolio return and bond return that we have up here. And let's go ahead and format that as a percent. So this investor, if they're comfortable with a standard deviation of 5%, they can get a return of 1.63%. If they want some desired level of risk of only 1%, their return is going to be 0.73%. So the less risk they're comfortable with, the lower their return is going to be. The more risk they're comfortable with, the higher their return can be. But that trade-off is always going to be there. We're never going to see a higher return and a lower level of risk. Now what you can do to play around with this is you can adjust this risk-free rate. So for example, let's set the risk-free rate to 1%. We can go back to our solver. Don't change anything. We're still maximizing the Sharpe ratio subject to this constraint by changing the weights. Hit solve, hit OK. And now we have a new portfolio. We now have a portfolio that has different shares of stocks, different shares of bonds. Again, the only thing that changed was the risk-free rate. So let's say the risk-free rate, oh, what have I done? So let's say the risk-free rate goes to 0. All right, so let's say the risk-free rate goes to 0. We have to re-optimize the portfolio. Hit solve. Notice our weights change. If the risk-free rate is 0, so bonds aren't paying anything, we now have a new allocation to also achieve our desired level of risk of 1%. So this is what's going on behind the scenes in a lot of financial planning offices, where you meet with your client, you observe, you get some measure of their risk tolerance, and then you have to allocate things certain ways to achieve that desired level of risk. Most people aren't doing this sitting in the office. If you go to Raymond James, your financial advisor doesn't have a spreadsheet like this, but there's something like this going on behind the scenes at some point. But if you can work through this, you should be able to optimize portfolios. You should be able to pull the returns, figure out what the current risk-free rate is, and start making some allocations and see how that changes things. But again, this is minimum variance and maximum Sharpe. We only do the minimum variance as a starting point. The maximizing the Sharpe ratio is really the main objective here. And then trying to figure out how to allocate for a desired level of risk and finding the return on that portfolio.